Welcome to the lecture on programming, data analysis, and deep learning in Python. I have two announcements, and the first one is that we fixed the problem for the computer scientists, and all computer scientists can now attend this lecture and get this to their degree. And the second announcement is that we would kindly ask you to submit in pairs. We got a lot of individual submissions for the exercises, and the people who are grading correcting the assignments are a bit overloaded. So if you can find a partner and submit in pairs, and that will help the situation a lot for the team. Okay, so last week, are there any questions so far regarding the lecture or the exercises? Okay, last week we finished with lists, and we saw that we can define a list, such as just by saying some list M is, and then we use these brackets, and we add a number of elements. And M is now this list, and the type of M is still list. And we saw that we can easily get confused with lists regarding which object is which and which reference is which. And I showed you a kind of diagram that you can draw. So we took a piece of paper, we split it into references and objects. And what I did here is I created a new object of type list with 6 positions, 0, 1, as such. So this is an object of type list. And I created a reference called M that points to that list. And these positions in the list, they are numbered. We start counting at 0. 0, 1, 2, 3, 4, 5, 6. Oh, 0 to 5, sorry. And the elements that are in there are 2, 3, 5, 6, and 1. So we created further objects. 1, 2, 3, 5, and 6, all of type integer. And then the list pointed to these objects. So the first position pointed to the 2. The second position to the 3. Then the 6. And the 1 and the 2. 2, 3, 5, 2, 3, 5, 5, 6, 1, and 2. And there's a small detail for you here. Each integer only exists once in the memory. So the 0 and the 5, they both point to the same object too, but it doesn't really matter for you, much for you. And now what we can do is we can change some of the objects. So for example, we can say that M at position 3 should be a string. Hello. Now we created a new object, which is this string hello. Hello. It's a new object of type str, and it's this object, this list element now points to this object. And list elements can even be other lists. So we can create a new list. One funny thing that we could do is we can create a new list M2. And we can convert, tell me if you're too confused, right? But we can convert this string hello to a list. You can say list hello. So what we now did is we have the string hello here, and we convert it to the list of the individual characters, right? And now what we can do is we can, I probably don't want to draw that completely on the blackboard, but we can say m at the position -1. So remember, if we take negative numbers, we count backwards, is M2. And now M is this list. So now we have this new list that we created. Where all these individual elements point to hello. All these are individual strings. So all these are individual objects now. And this is an object. And we created a reference M2 that points to that list here. And now we set the last element of M, we make it point to that new list. So this element, position 5 here, this now points to this list. So it can easily get a little bit complex with lists.
Excuse me?
Yes?
Can you use the list operator with all data types?
I don't know. Let's try. So what a computer scientist would do now is just to try. So let's put an integer into a list. No, that doesn't really work. So I think it only works with sequence data types. So with any list-like data types. So I think with integers and floats, it doesn't really work. But with because I mean it's quite clear for an integer and a float, it's not really obvious how to convert it to a list, right? For a string, it's more clear that you take the individual characters.
Can you use it to convert M to one list?
M is already one list.
Yeah, it is one list, but it contains a list. So could you use it to break?
To flatten it?
Yeah.
No. Because M is already a list. If you convert a list to a list, I think the sensible thing is that it's still a list. It's still the same list. But we can try one funny thing. Let's try this. M at position M is M. Actually, I don't know what happens. Does anybody have an idea of what could happen? Yes?
Would it be like an infinite loop?
Yeah, let's try what happens. Oh, it's completely fine, so Python doesn't complain. But now if we want to print M, I hope the computer doesn't crash. Oh, it's okay. So it prefers not to show the first item. Because now what I did is I made the first item of the list, m at position 0. Where does this point now? Can anybody say where this list element points? Yeah? Yeah, to the list. To the same list. So now I did this. So you can do this, no problem. But this one is a bit, obviously now it's very difficult to print. Let's see what happens if we print that list. Okay, it prefers not to show the first item. Because it's like two mirrors, right? It's like a mirror in front of you and a mirror on the back of you, so you see it yourself infinitely often. Okay, let's delete this item. If you want to delete an item from a list, you can simply say del m at position 0. And now it's gone. The first item just got deleted. We already talked about the append operation last week. We can say m dot append, and we can append another list, for example, 1, 2. So now the 0, 1, 2, 3. The fourth element is a list now, and the last element is also, it's a different list. We can also insert items at certain positions. Say that we want to insert the string high at position 1. We can say m.insert at position 1. We want to insert the string high. And this is different. So you see what happened is that the 5 got pushed over, right? So all the elements got moved one to the right, and at position 1 we inserted this new string. So this is, if you look at this diagram, what this does is really inserting a new element here. And now, of course, all these items have to be renumbered. So now this is 1, 2, 3, 4, 5, 6. And this one now points to a new string high. If we say del, here we have to give the index of the element that we want to remove, but maybe we want to remove a certain item. Say we want to remove the 5. We can say m.remove 5. Or maybe we want to remove the string hello. And now what Python does, it looks through this list and it searches for the string hello, and if it finds it, it removes it. What's a bit interesting here, if you have a list and the same item is occurring multiple times, does anybody have an idea what will happen? Yeah, one hypothesis is all the 6s will be gone, and the other hypothesis would be? The first 6 will be. Only the first 6, oh. So what we will do is we will just try what happens. Oh, there's no 5. Yeah, obviously, that's a typo. Okay, so if you want to remove something that's not in the list, you get this exception. Okay, let's look into the list. It's only the first one. Okay. So the computer science way to test something like this is just to go ahead and try and see what happens. Then there's an interesting method. It's m.pop. And this is sometimes useful if you want to use a list as a stack. I think you don't really, we'll cover this maybe later in the lecture. So what m.pop does, it gives you the last element of the list. So this was the list m. And m.pop gives you the last element, and it also has a side effect that the last element disappears from the list. So m.pop removes the last element from the list, and it gives it to you. You can also, so what we saw this append operation. So maybe we take M3 append 1, 2. So what the append operation does, it now takes this list and appends it as an element at the end of the list. But sometimes this is not what we want to do. Sometimes we want to append or to extend the list by all these elements, right? So maybe we want to have a new list that has the elements 1 and 2 as additional elements at the end of the list. And to achieve this, there's this operation extend. 1, 2. And what this does, it takes the individual elements of the list and it just extends the list by these individual elements. So it really depends on what you want to do. Either you want to have the new list as at the end of this list, the entire list as an element of this list, or you want to take all the individual elements of this list and one by one extend the previous list by all these individual elements. Oh, let's look at this list M, maybe. So maybe we want to get this letter E. Does anybody have an idea of how we can get this letter E from the form M? Yes?
Multi-dimensional arrays that you access to position 5 in the list and then to which level?
So we first access position 5, 0, 1, 2, 3, 4. Oh, I guess we better go for 4. Yes?
And then the letter you want to search in the second.
Like this?
Yeah.
That works. Yeah. So if you want to access lists inside lists, you just keep adding brackets depending on how deep you want to go in that list. So we had this list M3. This is this list up here, and maybe we want to count how often the number 2 appears in there. We can just use count. And the 2 actually appears 2 times in this list, once here and once here. Okay, let me confuse you a little bit. We will need a diagram for this. Okay, let's create a new variable a that is 5. And then let's say that b is a. And now let's say that b is 3. Or maybe we can say that a is 3 now. What is b now? Does anybody have a guess of? So I set a equal to 5, I set b equals to a, and I set a equals to 3. So what is now the value of b? Yes? B is 5. Okay, let's have a look at what's going on. So I have a new object, 5. Now a points to that object. I have a new reference a that points to that object. Now B points to the same object that A points to, right? That's what I say by mean by saying B equals A. So B equals A. So this cannot happen. So this is not possible in Python, right? References cannot point to each other. maybe so this is impossible. B points to the same object that A points to. So B now points to the 5. And now I say A equals 3. So I create a new object, 3. And then I say that A points to this new 3. Oh. And after that, B should still be 5, hopefully. Let's try. Okay, well, B is still 5. So this is a point where this kind of diagram can really help. Now let's do that slightly differently. Let's say that A is the list 1, 2, 3. B equals A. And now let's say that A at position 1 is 5. The question is, what is B now? Can you think about that? Yes, in the back? 153. Mm-hmm. Yeah. Okay, let's draw a small diagram. So I create a list. I create a list. 1, 2, 3. And then A points to this list. Then B points to the same list. B now points to this list. And now I take the list A at position 1, so this one, and I set it equal to 5. So I create a 5. And I make this one point to this 5. And now if I ask for B, I should get this list 1, 5, 3, right? Because A and B are pointing to the same list. Okay, so B is now the list 1, 5, 3. Now, sometimes this is what you want, what you actually want, but sometimes in the future we will want to actually work on this list. We want to change the list that B points to without affecting the list that A points to. Right? Say you want to do some algorithm and you want to sort the list that B points to, but you don't really want to change the original list. So how do you do that? Does anybody have an idea of how you could do that?
Can we just somehow copy it?
Yeah. That's excellent. So maybe if you're very naive, you would simply say A is this list and B is A.copy. That would be simple. Then A at the position 1 is 5. And let's hope that B is still the original list. That works. So let's do a small diagram to see what happened. So I create a new list. I say A.copy. So I create, this list gets copied. And what this copy does, it creates a new list where all the elements point to these numbers. And now I say B should point to this A.copy. And now I let A at the position 1, I let this point to the 5. We have a 5 here. And now B still points to this list 1.3, where A now has the list 1, 5, 3. This can sometimes be a bit tricky. Maybe let's do a slight variation of this. I forgot what I wanted to do. So I wanted to create this list. Then I copied the list. Now A at the position 1 at position 0 should be 9. What is B? Can anybody say what B is now? Can you think about that? Yes? Okay, let's draw a small diagram to think about that. Okay, let's get rid of this. So what was the situation? A is the list 1, 5, 6, and 3. So here we have a new list. And a 5 and a 6. Then we copy A. We copy A, so this creates a new list. Where this points to this 1, this points to this 3, and this points to this list up here. And B points to this copy. And now we go into A at index 1, this is this list, at index 0, this is this list, and we set that equal to 9. So here we remove this link, we create a 9. And this now points to the 9. If now we look at B, we get this list, which is, the first element is a 1, the last element is 3, and the middle element is this list, which is now 9, 6. So you have to be a bit careful with the list copy operation because it only copies the first level, right? It doesn't copy recursively. It doesn't do a deep copy. So if you wanted this really to, so B is now 1, then the list 9, 6, and then the element 3. You need to do a deep copy if you wanted to prevent this effect, to go recursively down the lists. All right, this is, I think, a bit advanced topic, but I think the main point of this is if you get confused, draw one of these diagrams, and it will be usually obvious from the diagram what happened, or why something did work, or something didn't work. Okay, then we can also, let's go back at our list M. You can also test whether an element occurs in a list simply by saying 5 in M. And what this does, it tests whether the list 5, whether the object 5 occurs in the list M. And it does. Maybe, should we go back? Are there any questions about this? For whom is this clear, what happened here? Who's confused by this? Okay, yeah. So I think you should be a bit confused. I think what really helps is after the lecture, you go back and you draw some of these diagrams for yourself, and then you will see what's going on. Okay, that's everything I wanted to say about lists. Are there any questions about lists? Okay. Has anybody worked with arrays in a programming language such as C or Java or so? Okay. So what's annoying about arrays is that after you create them, you cannot change the size. So I think the big strength of lists is you can change the size as you want. They can get bigger and smaller if at the beginning you don't know how big they will need to be. The biggest downside, in my opinion, of lists is that this operation here, to test whether the 5 occurs in the list M, that operation is very slow. Because what Python has to do, it has to go through the entire list, look at each individual element, and see whether this element is a 5. And of course, it's no problem if you have a small list, but imagine you have a big list of, I don't know, a few gigabyte, and then you have to look at each individual element. That can actually take a long time. And the main reason, so actually what Python provides a different data structure that fixes exactly this problem. The problem of checking whether an element occurs, which is very slow with lists, is very fast with a different data structure that's called a dict. Has anybody seen a dict previously, or hash table? Yeah. So in other programming languages, they are called hash tables. Yeah, key value pairs, exactly. So, okay, so this is what dicts are good for. And dicts are like dictionaries. So imagine you have a dictionary that translates from English to German. And you define them not with these brackets, but with these curly braces. Then you enter all these possible translations. So maybe you want to translate T. The word for T is T in German. I is ich, and like is mag. Okay, so this is type of D is dict. And if you look at this, these are always key value pairs. So we have one word in English, and we translate it to the equivalent word in German. The English word is the key, and the German word is the value. So T translates to T, I translates to ich, and like translates to mag. And what we can now do is we can translate individual words. We can say dict of like, and this is mag. So it's really like a dictionary. So you can enter words, and then you can look them up under the English name, and it gives you back the German word for it. And this action is super fast. It's much faster than doing something like this with lists. And if you want to have a fast program, if you're programming something and you want it to be fast, it's often a very good idea to use dicts as much as possible, because dicts are extremely fast. So you can translate entire sentences. For example, you can, let's make a sentence. I like T. And then we can translate that to German by saying D of S of 0 is ich. D of S of 1 is mag. And D of S of 2 is T. So you can go through entire lists of words and you can translate them. You can also check whether a certain key appears in the dictionary. So you can say like in true. This is the same that you can do for lists, but for dicts, this operation is much, much faster than it is for lists. You can get all the keys if you want. Maybe you want to get all the keys as a list. So I can say d.keys, and I convert. So this gives me all the keys, and I'll convert the keys to a list. This gives me a list of all the keys that appear in the dictionary. And then I can also get a list of all the values in the dictionary. And I can also get a list of all the key value pairs if I want. I can do a list of d.items, and this gives me all the key value pairs. So I have the key value pair where the key is t and the value is t, and the next key is I and the value is ich, and so on. I can also delete key value pairs with del. I can say del di. Maybe I don't need the translation for I anymore. And then I still have the other key value pairs, but the I-ich pair was deleted. If I look up keys with this operation in this way, I can do that. But one property of looking up keys with these brackets is that if the key does not appear in the dictionary, I get an exception. So I now gives me an exception. It says key error, the key I doesn't appear in the dict. If you don't want to get such an error, if you look up for a key that doesn't appear in the dict, you can use the get function. You can say d.get, and it's exactly the same if the key appears. So d.get of t is t, but d.get of I doesn't give you an exception. Actually, it gives you, we have to look up what it gives you. A is this. No. Actually, we cannot. So if we look into it, there's nothing, right? A is, there's nothing in A. So we have to print it. And it's none. And none is actually a special object in Python, which is the none object, which you get whenever there's nothing. So it's a special object for saying nothing. So none. Maybe we can look up the type of the none object. Type of A. It's a none type. Maybe not very creative. So it's an object of type none type. So sometimes if you do something and some functions might give you a value of type, might give you a none back. If, for example, this get function here. Okay, are there any questions about dictionaries? Yes?
So those dictionaries are some kind of arrays, right? So you can't add a new...
Oh, you can add. Yeah, I didn't show you. D of, let's translate car. So you can add. Thanks for the question. I forgot to show this. So you can add as many elements as you want. So maybe D of house as house, and so on. So you can keep adding elements as you like to a dictionary, yes.
The dictionary is only able to translate one way?
Yes. You can only translate keys to values. You cannot translate back. I think if you want to translate back, you have to create a new dictionary. You have to get all the keys, all the values, and then create a new dictionary where it's flipped. I'm not sure that there's a more elegant way in Python, but the purpose of dictionaries is only one way. It's only to go from keys to values. So if you want to have a German-English dictionary, you have to get a new dictionary. It's really like dictionaries consist of two parts, right? One is English-German and the other one is German-English. Yeah, I think you were next.
Can we match one key to multiple values or multiple keys to one value? Because language is quite complex, so they are
Multiple keys to the same value is no problem. It only cares about uniqueness of keys. But the other question was, one key to multiple values is impossible. Because Python, the dict always gives you one value back, and if there's multiple values, it doesn't know which values. You can, as a value, have a list of other things, obviously. But the key always needs to map to one object, and then you need to hack something if you want to have multiple things in there. I think you were next.
Which data types you can use for values and keys?
I think that's the next line that I wanted to show you. The answer is, let me answer that in 1 minute. Yeah.
So you said that the dictionaries are much faster than lists and arrays. You said dictionaries are much faster than lists and arrays.
There's no arrays don't exist in Python. There's no arrays except in NumPy, which we will cover later in the lecture. So in vanilla Python, arrays don't exist. Dicts are much faster than lists for this in operation. So to test whether an item occurs in there.
Is it because it doesn't have to traverse over the whole list? That's why it's faster?
Yeah. I decided to push that back in the lecture a little bit and explain you later how dicts work. But dicts have a very smart way of doing it, so that they can directly go in one step. So if you have a list that is n items long, right? In order to search for a specific item, you need, in the worst case, you need n steps, right? So the longer the list gets, the longer it takes you to look up an item. And for dicts, it always takes you one step to look up an item, regardless on how big the dictionary is. So you can have a gigantic dictionary, and it doesn't matter how big the dictionary is, you can always look up keys in one step. And there's a smart way to do that. Maybe you can think about whether you can invent that for yourself, but I will explain you later in the lecture how that works. But it's very nice, especially if you have very big dictionaries. It doesn't matter how big the dictionary is. Your dictionary can be a terabyte. You can always look up values in one step. And that's pretty cool if you want to work with really big data sets. Okay, and then one question was, what data types can be keys and what data types can be values? The answer is, a value can be anything. Any object can be a value of a dict. But for the keys, it's not that easy. Not any object can be a key. Okay, let's do something. Let's add one thing. I think we had a question before whether. No, it's unrelated to your question, sorry. So let's say that we have a list. I didn't use E. We have a list, E, that, let's translate something. Superman, maybe. Maybe we want to translate Superman. And for some reason, I want to keep the words separate in the list. So I want to add now to the dictionary D, I want to add something where the key is this list Superman. And the value is, I don't know, what is it in German? Superman, maybe? Okay, let's try that. And what you get here is you get on the creation here of while you're trying to enter this key, which is a list, into the dictionary, you get an error, and it tells you unhashable type list. Okay, I will explain you later what this problem is, not today, because we need to cover other things. The problem is related to this here. So keys to dictionaries can only be things that can never be changed. If you would change a key afterwards, after adding it to the dictionary, the entire dictionary would fall apart. So the way the dictionary is built depends on the fact that the keys can never be changed. Is this clear? So the keys need to be, in Python it's called immutable. So they cannot be, immutable means they cannot be, mutable means it can be changed, like a list is mutable. A string, for example, is immutable. Once you create a string, it can never be changed afterwards. Yes?
And does that mean that the key can be a string, but it cannot be a variable, which is also a string?
So keys can never be references. Keys can only be objects. But there are certain kinds of objects. For example, there are lists which can be changed after you create them. And for example, strings cannot be changed after. So if you try something like this, s equals hello, and then you say s at the position 0 should be a lowercase h, then it says a string object does not support item assignment. So once you create the string, you cannot change the string. You have to create a new string that's different. And the reason for this is that you want to be able to use strings as keys in dictionaries. I think that's the main reason that strings cannot be changed. So dictionary keys can only be objects which cannot be changed. Maybe I'll write that down. Dict keys must be immutable. Immutable objects are ints, floats, string, not list. So lists are mutable, so they cannot be used as keys. Okay. But in some cases, you want to have a key for your dict that's a combination of multiple things. Say you really want this Superman to be a key for your dict. What we would need is we would need some kind of list that is immutable. So it should be more or less exactly the same as a list, but once you create it, it may not be changed. And there's a data type in Python which does exactly that. So this data type is like a list, but it's just immutable in order that it can be used as a key in a dict. And that data type is called a tuple. And it's really, it's like a list, but it's the only difference basically is that or the main difference is that it's immutable. And let's copy this. And you only have to do a slight change. The only change that you have to do is instead of these brackets, you just use normal braces. That worked. So D is now, we now have a new key value pair here, where the key is the tuple Superman, and it translates to the string Superman. and the type of E is tuple. I would say that lists are used much more often than tuples in Python. And one of the main reasons to use tuples is really if you want to have it as a key in a dict. And I told you that tuples are immutable. So we have this tuple Superman. And now if we want to say E at the position 0, we want maybe to capitalize it. So we want to say super. This doesn't work. It says tuple object does not support item assignment. So tuple is really like a list, but it's, the only difference is that it's immutable, or the main difference. And I think tuples support mostly the same functions as lists. So, for example, you can say man in E. I think that should work. Yeah. And len of E. Oh, that needed some two elements in E and so on. Are there any questions regarding tuples? Okay, now there's one detail on tuples that I wanted to show you because you might stumble upon it. It's a small syntactical difficulty that the creators of Python ran into. So if we have a list L, then we can create an empty list. That's a problem. So L is now just the list with no elements. It's just an empty list. We can also create a list with only one element. No problem. And we can create a list with two elements. No problem. Oops. To show you the list. No problem. Let's try the same as tuples. We create an empty tuple. No problem here. Now we want to create a tuple with only one element. Does anybody see something? Does something occur to? Yeah.
This looks like an integer to me.
Yeah. So T really looks like the number 1 and not the tuple with the 1. Let's check the type of T. It's an integer. It's not a tuple. Does anybody have an idea what happened? Why didn't this work that T is a tuple with the one element with the integer 1? Yes. I didn't.
Maybe you just say storage, so to be safe as it means instead of a tuple.
Yeah. No, it's not because of storage. It's an interesting idea, but the main problem are these braces. Does anybody see a problem that can be interpreted in multiple ways here?
It's a mathematical operation.
Yeah, for example, you want to be able to do something like 1 plus 2 times 3, right? And here you really need these braces to define the operator precedence, to say that the addition should come before the multiplication, right? And Python cannot, for Python, this is the function of the braces here. So it says number 1, and I just want to do, I want this to be done first. So I put this into braces. And Python is impossible so for example, here what we want to do is we want Python to do this calculation, right? We don't want to add the numbers 1 and 2, add this into a tuple, which contains the number 3, and multiply this tuple by 3. That would be very strange. So Python is not able to interpret this as a tuple. Does anybody have an idea of how we can hack this to make clear this should really be a tuple? Yeah, we need some kind of strange hack to say that we really want a tuple this time. And what the Python creators decided on is this. I think it's not really nice, but that's the way it is. So now T is a tuple, and the type of T is tuple. So if the only difficulty is if you want to create a tuple with only one element, then you need to add this 1 comma to say that this should really be a tuple. Okay, you can use all the functions that you can use for lists. You can slice tuples. Let's do a tuple that's 1, 2, 3, 4, 5. And we can say T starting at position 2, and then until but excluding position 4. So this gives you a new tuple with these 2 elements. Then you can ask the tuple for the index of the number 3. 3 occurs at position 2. You can say 3 in T. That's 2. You can count the number of 3's. T count the number of 3's. It only occurs 1 time. Yeah, now there's another advanced thing that I want to show you that it's a bit more complex. You can create tuples. So the thing that defines the tuples are actually not the braces, but it's the commas. So if you want to create a tuple that's 3, 4, 5, you saw the problem here that we need to add the comma anyways, right? So there's no way to drop the comma. So then the Python creators decided that, if we need the braces and the commas, we can as well drop the braces, right? So we can do this. And it's actually the commas that define the tuple. And this is sometimes nice if you want to get all the elements of this tuple. What you could do is v equals u at position 0, then x equals u at position 1, and y, maybe wx like this, is u at position 2. That works completely fine. W is now 4. But you can do one fancy thing. So if you want to be fancy, you can do this. Vwx equals u. And what this does, it is unwraps this tuple into these 3 variables. I think you don't really have to use this. It's some kind of advanced usage. You can always get around by using something like this. But if you see something like this in somebody else's code, then this here does exactly the same as this here. Yes?
What if you only have 3 variables and 3 elements in the tuple?
Oh, I don't really know. But I think the remaining tuple goes into the last variable. That's what I would guess. Let's try. Vw equals u. Let's look into w. Oh, no. No, too many values to unpack. Yeah. It just gives you an exception. So it's called tuple unpacking. That's the term. Yeah. But this is really a bit advanced. It's mostly for if you see somebody else's code saying this, then this is what it does. Any questions regarding tuples? maybe we should just remind ourselves. So until now we had integers, floats, Boolean values, complex numbers, lists, dicts, and tuples. I think that's the main data types that we have covered so far. There's another data type that got added only recently to Python, and that's a mathematical set. Set. Can somebody say what's one of the defining properties of a set? What would you expect a set? How would you expect a set to be different from a list? No sequence, yeah. The order, no order, no sequence. That's one of the properties of sets. There's no order in the elements. And there's a second property.
List doesn't have order as well. How does list have an
A list have an order. In a list, the elements always come in a certain order. It doesn't need to be sorted to some criterion, but each list item has an index. Yes? Yeah, if you add the same item multiple times into the set, it's still only in the set once. That's one of the defining properties of a set. So if you can't have the number 3 in a set like 5 times, right? And sets, I think most people would use a set if they want to have this property. If they want to have the property that the same item only occurs once. If you want to define a set, you use curly braces. So if you have a set with the numbers 1, 2, 2, maybe 1, 2, 3, 2, 2, 2, another 3, an 8, and maybe a 2 and a 1. So what would you expect? What are the elements of this list? Or how many elements, how many elements does this set now have? Yes? 4. Yeah, 1, 2, 3, and 8. These are the distinct elements in this set. So all the multiple, they just get merged. The type of S is set. It's just a mathematical set. And then you can do with sets what you expect to do with sets. And so you can do all this intersection, union, difference, and so on. So let's create a second set. Maybe 2, 3, and 9. And now, if you want to create the union of S and S2, you use this. Where's my pipe? Here. This means S union S2. These is the 1, the 2, the 3, the 8, and then the 9. So it's just a union of the 2 sets. And then you can also do the intersection of the 2 sets. These are all the elements that are in both sets. Actually, it's not the elements that are in both sets. S, 1, 8, and 9. Oh, I don't know what's going on. S, intersection, S2. That works. Actually, I don't know what this is doing. So I will look up what this is doing. Sorry. But you can use, you can do the difference of 2 sets. So you can do S minus S2. It's the 1 and 8. Let's check what S. S is still this list. You can check whether one set is a superset of another set. S is the superset of S2. So this is mathematical notation. This would be S superset S2. You can check whether elements are in a set. S 2 in S, it's true. And you can also add elements, S, add T. Now S has the elements 1, 2, 3, 8, and T. You can also remove elements, S, remove 2. Any questions regarding sets? Yes?
Maybe why is S not bigger than S2?
This does not mean bigger in the sense of the number of elements. This means whether it's a superset. So all the elements that are in S2 are also in S.
Oh, yeah,
This is what I meant with this superset.
yeah.
Any more questions regarding sets? I think sets are used much more rarely than lists. I would say lists and dicts are used most often, followed by tuples, and sets are not used that often. Okay, the final data type that you might be interested in, or you will probably be interested in, is files. So you will probably want to open files from your hard drive and write files to your hard drive, yes? Sets are mutable. So you cannot use a set as a key in a dictionary. Let's say we want to create a new file on the hard drive. This file should be called F. And I just say open, and then you give the name of the new file. Maybe it should be called file.txt. And you want to write into this file. So you say W for write. Okay, now what this did is it created a new file on my hard drive. It opens the file for writing. And now I have this file in this variable F. Let's see what the type of F is. Oh, it's this strange type. Now I can write into the file simply by saying f.write. Let's write a string in there. This is a file. You can say \n for a new line. I want to go to the next line. And now this file what you just wrote into the file might only be in memory. So this might be a problem if you write on a USB stick, and now it's not written on the USB stick yet, but it's only memory. So now if you pull out the USB stick, it might be that it's not on the USB stick. So you might want to say f.flush, which means write everything to the hard drive. Maybe let's write something more. f.write with some lines of text. And then let's close the file. Now the file is closed. I can remove my USB stick and so on. Let's open the file again. F2 is open. And this time, so I called the file file.txt. Now I want to open a file with the name file.txt, but this time I want to open it for reading, not for writing. So I don't have to say anything. And now I can say f2.readline. I get the first line. Maybe let's do the same thing again. f2.readline. Then I get the next line. So you can read a file line by line. Let's close the file again. Okay. So now you can write stuff that you calculated or that you did in your program. You can write it to your hard drive, and you can open it again and read it back in. Are there any questions regarding files or data types in general? Yes? The number of lines? Or the number of characters in one line, or the number of lines in the file? The number of lines in the file, I don't know. You have to go to the documentation, I'm afraid.
Is there any reason why the Python gives you the number of characters back that you wrote?
Oh yes, because you might, I think it's just a convention.
Okay.
It's just to say, oh, I successfully wrote 16 characters into that file. Yeah. Maybe you want to use that number afterwards if you, I don't know, want to do something with it. Good. No question. Okay. Any other questions regarding data types in Python?
Is it mandatory to like close the file?
I recommend to close the file before you remove the USB stick or you shut down the computer. I'm not sure what happens if you didn't close the file. I think it's a bit non-deterministic. If you didn't close the file, it might be that it wrote the file to disk, but it might be that the file is still in memory only, and Python waited with writing it to disk. Okay, so we are done with covering all the most important data types in Python. That's great. Now we might want to do some interesting stuff in our program. So now we look at control flow. So how you can actually control what your program is doing. Everything up to now, we just executed our programs one by one, one line by one, starting from we start at the top row, the top line, and we just keep executing lines. And this really limits what you can do, right? So who knows what if is? The if, yeah, okay. So you've been probably waiting for this. Because if you don't have an if, there's very little you can do. Let's create a new notebook. Control structures. Quite often you only want to do some certain things under some conditions. So, and then you can say if, or let's say x is 12, or x is 13, and then you want to say if x is bigger or equal than 12, then print bigger, and else print smaller. Oh, maybe we can say we can get a number from the user. Okay, now the program asks us to enter some number, and if I enter 11, sorry, I have to convert it to an int first. If I enter 11, or no, I entered the 12, I believe, right? So then I enter in 11. So now x is 11, and then I check here if x is bigger or equal than 12, which is not the case. So I go to the else clause, and I execute whatever is written under else. And if I execute the same code and I enter 13, then I test if x is bigger or equal than 12, which is now true, then I execute this code. Right? So if, it's just a way to say, if something is true, do the thing, and else do the other thing. Maybe you want to do multiple things. And in programming languages such as C or Java, if you want to do multiple things, you would enclose them in curly braces, but not in Python. In Python, you just indent them to the same level. So if x is bigger than 12, do this, and then also do this. And only if x is not bigger than 12, do this. What I have to do is I have to use the same indentation for both of these statements. So now if I enter 14, I do both of these things. It's really important that you indent them to the same level. This doesn't work, right? So you really have to indent it to the same level. Sometimes you want to check for multiple things. So maybe you want to check for if x is bigger than 12, you say bigger, and then if x is equal to 12, print equal. And else print smaller. So now if you enter 12, so what Python first checks whether x is bigger than 12. This is false. Then it checks, then it goes to this else if, or elif in Python. It checks if x is equal to 12. X is equal to 12, so it prints this, it executes whatever is written here. Okay, I think that's sufficient for now. Any questions regarding if? Yes? Excuse me? No. No. The if ends whenever print, if you do something here, maybe it's a bit nicer to do this. If you write something that it's not indented, that goes back to the original indentation level, then this ends the if and it's executed in any case. So you don't have to say end if or something. Yeah.
Can you use elif several times?
Yes, you can use elif as often as you want. Okay, let me give you some code to demonstrate that. X is int of input. Maybe we want to ask for x. Let's get 3 numbers from the user. X, Y, and Z. And then we want to check which one is the smallest. So if x is smaller than y is smaller than z, print x is smallest. Let me copy and paste this. Oops. Now you have to be careful to indent it to the correct level. If maybe z is smaller than y, then x is still smallest. Now let's check where for the cases where y is smaller. If y is smaller than x is smaller than z, then y is smallest. And maybe y is smaller than z is smaller than x, then still y is smallest. And if none of this is the case, else print else z is smallest, right? Okay, let's add 3 numbers. X is 3, y is 56, and z is 9. X is smallest. So you can use an elif as often as you want. This code is very inelegant, right? As you can see here, it's, you really, if you really have to, if you really cover all the cases, this is really inelegant. Maybe we can do it in a more elegant way. Does anybody have an idea of how to write this program that checks for the smallest number more elegantly? I mean, here it's really difficult to understand whether the program works correctly, right? Or whether there's some bug in the program. Does anybody have an idea how we can change the program to make it much simpler? Yes? Yeah, let's check whether if x is smaller than y, and let's use an and x smaller than z, then x is smallest. Else if, then we don't need this case. We can kill this. Else if y is smaller than x and y is smaller than z, and then we can kill this case. So we just combined two elif clauses into one. I hope this is correct. X is 9, y is 1, and z is 12. Y is smallest. Okay, that works. Okay, is there any questions regarding if? Yes?
What is the type of the condition?
It must be something that returns a Boolean.
Can you write if 1 or something like that?
If 1, I think I would ask you not to do that. I think it works, but if you test for an integer, you can say that a is true, for example. You create a Boolean variable, and then you say if a print yes. So this thing here, after the if, can be any expression that returns a Boolean value. I think if you say if 1, that works, but please don't. If 0, yeah, then it's false. 0 is false and 1 is true, but I'm not a big fan of doing that. Just because it works, it doesn't mean that other people will understand what you're doing. I would prefer to write something if a is equal to 1, I think. It's a bit more. But there are some people who are of other opinion. Okay, so sometimes you want to do things only under a certain condition, and in other cases you want to do things multiple times. So who knows what a for loop is? Okay, not everybody. For loops are very useful, believe me. For loops. Say you have a very long list. L is a list with a lot of elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now you want to add all these numbers. Then you can say L at the position 0 plus L at the position 1 plus and so on. But you will go crazy if you try to do that. And besides, it only works, it doesn't really work if L has a different number of elements, right? So instead you can use for. You can say for, and then you have to create some variable for I. I will be each element that you're looking at in L. Let's create a new sum, S. Let's create I just create an empty variable S. And then for each element in this list, I want to add it to S. Now, if I do that, then in S, it's the sum of all the elements. You can also say for I in L, print I. And now you print all the elements. Yes?
Does it have to be I?
No. For hello in L, print hello. Exactly the same thing. It can be any variable. So what this does, it goes over this list, it assigns each element of them to this variable, and it executes whatever written in this for loop. You can also creating these lists is also can be quite annoying. So there's a command for creating this list with increasing numbers. L is and the command is range. Say you want a list of 1, 2, 3, 4 up to 10,000. Maybe let's do 20. This range starts at 0, and it gives you all the increasing numbers up to 19. So in total with 20 elements. So one thing that you will use very often during programming is for I in range 10 print I. You can also do for I in range 4 to 11 print I. Then you start at 4 and you stop at 1 before this 11. And you can say for I in range 4 to 11 with steps of 2. Now it only gives you every second element because you set 2 here. Okay, maybe in the last minutes I give you the last kind of... are there any questions regarding the for loop? Yes? The range in general or this particular range? Okay, so range allows you to iterate over the numbers from 0 to 1 less than the number that you gave as an argument. And it also allows you to start from a different number, so you can start from 4. And it also allows you to add not 1 at every step, but add 2 at every step, or add 3 at every step. Okay, then there's another type of loops that's called the while loop. And maybe we have a variable I, which is 0. Then you can say, while I is smaller than 5, print I. And then I should be 1 more. I equals 1. I equals 1, I plus 1. And what the while loop takes, it's just this, it takes a Boolean value here, and it executes this loop until while this is true. So if you want to crash your computer, you can do while true I equals I plus 1. I prefer not to execute this. This is what's called an infinite loop. Okay, so I think we have covered most of the important control structures. Are there any questions regarding if, for, and while? I think you will need all of them in the exercise sheet, so you will get some time to practice this. Okay, then let's meet next week. Thank you.